Hi, I'm Jay Krishnan. I'm from Parla Transmedia.
Hi, I'm Rajesh, working with Alliance.
Good evening, friends. This is Lakshmikant.
Yeah, I'm Naveen Naushad. I have been an Android developer for the past 4 years.
So those who came new, could you please introduce?
Myself, Renish Ravindran. I'm working as a trainee software engineer in Alliance Cornell.
I'm Vishnu. I'm in training as experience. I'm working as a trainee in experience.
Okay.
I'm Shivashandani G, doing MSc IT in IIT.
Hi, I'm Rini. I'm from Experion Technologies.
Hey, good evening. Renu from Experion.
Hello, I'm Mohana from Polar Software.
Himagishore from IBS.
Ramakan from IBS.
So
My test system starting here. So you start sharing and switch that on and you switch back to the slides. Okay. Problem.
I know people will always catch me. So knowledge is key in DBT. Bring your own container. That's the message that DBT tells us, right? And I've been here for over the last 2 years, and there's like a wealth of information that is being shared across. So I believe when we are in US, there are a lot of keynote sessions, right? I know we may not be able to attend all of those, but this is more of a brief of all the keynote sessions that are taking place across the globe. So today, I think we have the big data stuff. So I think after this session, I think everybody will have a brief idea about what big data is, and I believe some hands-on or some ideas as to what we can expect, right, from big data.
okay, thank you, friends. So everyone, we actually start with a session called Techbites, where we discuss new things that happened in the last 1 month. Then we go into big data or whatever the topic is for the month. So I would like to Mini to start the first session.
Hi, good evening all. I'm Mini. I'm working as an iOS developer in DBG.
I'm here for the Techbites session of 24th Coffee DBG, as like most of people mentioned, like this is the second anniversary of Coffee DBG, so it's a very special day for us and for all technological enthusiasts. So let's check out what we have got for you today. Moving on to the first one, it's virtually anything. So you all know, like more and more virtual products are coming into market day by day, which is like getting involved in your day-to-day life. So we have two products in the past month. One is related to health and fitness, and another one is related to games. That's for kids. So let us have a closer look at the first product, that is named as White Run. It has got a docking station. The main feature of the product is you can use your own cycle or your whatever device, whatever the vehicle you use for your cycling purposes, like that. You can dock that the vehicle in that docking station, and with the help of Samsung Gear or some widescreen, you can experience the virtual environment around you. We have got a video about that will more than explanation, that will give you an insight of how this works. Sorry, the video is having some problem. So it is a device. The docking station has got a microcontroller. So you all know microcontroller is. So the microcontroller simulates the speed, steering, and the resistance based on the terrain that you are currently experiencing. So you are in a mountainous terrain and you are riding up. So you will feel the resistance, and you have to put more energy to go up. So this is what the virtual reality this device is providing you. So sometimes you will get bored with the terrain that comes with the package of this device. So you can buy more and more terrains from the app store of this device. This device is available at a price range of 400, and it is supposed to get delivered by the end of this April. So moving to the next one, that is Lumos. Lumos is from an Italian company, and it will give your kid a real-time experience of gaming. Like it is a device that is built upon this Android SDK. You can control the game via your iOS device also. The main feature is this has got gesture recognition. So if you are playing, you have to handshake. If you have to stumble, walk, everything you can. This real-time experience you are getting. So that is a product. Moving to the next one. We have witnessed another product. I would call it as a wonder from Intel. It is called Intel Compute Stick. Then what this device you plays is like you have got a device that is of your palm size, and you can convert any HDMI screen to a personal computer. So it is like you can create a computer and you can do all the steps with like a computer. This device has got Bluetooth connectivity, Wi-Fi, then USB port, and this is a chargeable one. So really, it is a wonder device, right? The next one is Google Handwriting. So I hope most of you have experienced the Google Handwriting. So Google Handwriting is something. It's a new input to the Google Android app that Google has provided. It is like you can write text. And it supports cursive writing. You can create emojis. Then it supports 82 languages in 20 different scripts. It's works without internet connection also.
So hope everyone has already installed in your Android device, right?
It's available in Google Store. The next, it's another product from Intel. It is a microcontroller chip. It is called Curie, and this is curious button because it's really curious because it is mainly designed for wearable devices. It has got Bluetooth connectivity and it has got a chargeable circuit. Currently, it is not available in public, Intel has made some contracts with some big brands like Nike and all. And the products from these big brands, wearable devices from these big brands, are supposed to enter market by the next quarter of 2020. Then Facebook is really getting transformed day by day. It is getting like more and more features, like it's introducing more and more features. Last month it introduced one new app for Android Android users. It's called Hangouts. It's just like a caller app, the caller ID app. So Facebook has got a large database, as we all know. So it shows the caller details, and it has got the caller blocking properties. Then it is under testing in 3 markets: US, Brazil, and Nigeria. Hope it will be available soon for iOS users also. The next one is Facebook is with profile name pronunciation. So you might have experienced difficulty in pronouncing some friend's name. You are entering on another user's profile, and you might have experience like how to pronounce his name. So Facebook is bringing up this feature to explain. If I currently it is in beta testing, but Facebook has enabled this feature for few profiles. And if you want to know whether it is enabled for your profile, there is a way. Like you have to go from about, details about, and then if you are with that feature, then the play button will be there. Facebook is providing with the different options to pronounce your name. But if you are not satisfied with that, you can upload your own version of your name. And the last one is like Debian OS has released its most stablest version, that is Jessie. And last 25th, we had one release party over here. And in that release party, Mr. Neil McGowan addressed us over Firefox Hello. And we had a very wonderful session on the controversial topic, net neutrality too. So these are all things we have got for you this month. Now I would like to welcome Mr. Mohan for the data session. Thank you.
Thank you. Thank you. Am I audible? Yeah. Hi. Welcome to the day that begins with a technical difficulty, probably technical difficulties. Yeah. So, yeah, I'm Mohan, a free software enthusiast and a big data follower for the past 6 years. And I work in USC Global. And let's not talk about me. Let's talk about something that we came here to talk about, right? So, yeah. Today we are going to drill into big data. I'll explain you why we have to drill into big data later. So, big data. So that is the topic that we're going to see. We'll cover some topics that's been mentioned here. So let's go ahead. So what is big data? But before going to that, any of you have experience in big data before? It should be interactive. Let's make it interactive. Yes, please. Yeah.
I worked in a big data startup called Techbites.
Okay, great. Anyone else? Don't be sad. Let's make it interactive and make it funny. Okay? Because we are having a coffee at DBG, right? Right? Yeah. So yes. Anyone else? Okay. So let's ask others.
What are the questions in your mind that when you came for a session for big data? There may be a lot of questions that is to know. So there may be some simple, silly questions also. The Coffee DBG is a session where we try to find answer for all those simple questions so that we get a better picture of the real topic. So,
yeah, this would be the right time, right? So probably before starting the session, just shoot out your questions. We'll see how we can answer that.
Simple question about the topic. Because normally when we go for bigger sessions, we would never get a chance to ask those questions, and we always feel shy to ask questions, whether it's wrong or so. Here, that is not a problem. So, any questions that is in your mind or your expectation?
What is big data?
That was the question that I was about to ask you people. So yeah, so we'll start with the group. Any other questions or information that you like to require? Yep. Yeah, it is.
Yeah, so I think questions like what is the traditional, the data relational approach that flies away when you consider big data, and what is the real big height of big data in today's world? why are people behind collecting maximum information, which may not be meaningful or handful, but they see a big potential in a great business, right?
Yeah, we'll be answering that in the session. Anything else that you want to know or you're eager to know about big data?
There are questions.
Actually, I have managed 1 terabyte of data.
Okay.
What's the difference between?
Okay. Okay. 1 TB, right? Yeah. 1 TB. Yeah, we'll talk about it. Anything else? No. Okay. So let's start with the first question. What is big data? I'm asking you. I'm not answering that. I'm asking you. So what is big data?
The answer is simple, right? It is a big data. Data is very big.
Right.
The data is very big, which cannot be held by the traditional database management systems. That's why it's named as a big data.
Yeah. So you did your homework. Thanks. So yeah. So it's big. That's why it's big data. A data which cannot be handled by any relational database systems. That is what is called as big data. Meaning, like, what is like we have an information that person here has handled 1 TB data, right? We're not talking about 1 TB, 2 TB, 3 TB. We are talking about petabytes, zettabytes, and exabytes, which is like trillion gigabytes. If that answers your question, right? So we are talking about data which is not we cannot store it in a simple system that you have in your machine, right? So you're talking about data which is huge, big. So petabytes, exabytes, and zettabytes. That's what they call. So we'll see them one by one. So we already got the definition of big data. So usually, if you look at relational databases, it's all structured. You have a column name. You know what content is going to flow in. You know everything that's going to be stored, right? But here it can be an unstructured data. For example, if you are logging into a website, the server will have a log, right, for that particular website. Which link you click, the server might be having the logs for that. Wherever the error is, the error will be logged. So this is an unstructured data, and this data can be processed using big data, and you can get results out of it. So big data, the term when the data that we started receiving grew larger and larger. So there was a survey where we got information that in the last 2 years, we got data which is equal to the data that we collected the day that the data started to create. So the volume of data in the last 2 years is equal to the data that has been created before that. Make sense? Are you all in mute mode? I do have a remote. Probably I'll try with this. Yes? Yes? Please open your mouth whenever required or whenever you think that you have to tell something. And there is nothing called a wrong answer and nothing called as a stupid question. Feel free to ask a question, feel free to answer. Okay? Okay, so about big data. And during 2006 range, Gartner is one of the leading companies in data analytics and big data. So they came up with 3 V's, where they put some data as big data based on 3 things. One is volume, velocity, and variety. Whenever there is an increase in volume of data that comes in, and the velocity of the data that is flowing in, and the variety of data. Like, how many of you have Facebook? Everyone? How many of you like posts every day? You don't hit like. How many of you visit Facebook every day? Okay. So how many of you post your photos? Yeah. There, what are the options you have? You have an option to chat with your friend, you have an option to click like, you have an option to send a friend request, right? Comment. Yeah. So anything else? You can do a lot. Like even right now they introduced the concept like you can reply to a comment. Previously it was not there. Right now they introduced. So every single entry that you make is counted or stored for future processing. You can take, I created my Facebook in 2008 and I can take my data till 2008 from if I access now, right? They store all the data in their machine, right?
So that's what they call as 3V, but recently they brought in a new factor called veracity, which I'll explain later in a few minutes. So yes, so we'll see one by one. So what is volume of data? So what volume are we talking about? How much data are we getting every day? So it's been identified that we are getting about 2.5 quintillion data, which is 2.3 trillion gigabytes of data in a day. In a day. I'm not talking about month or year, it's about a day that we are getting this much data. And what all data do we share or store? A smartphone. Everyone has a smartphone, right? So I'm not blaming Google, but yeah, Google takes data from my machine for improving their products and helping us in enhancing our experience in it, user experience. So they collect data in every smartphone. Facebook collects data, whatever you add, post, comment, or reply, or like, they take the data. So these all data we store, but what are we not storing? We are not storing a lot of data, right? For example, you might be having a remote to your TV which is already connected to Wi-Fi. At what time you switch on, at what time you switch off. We are not taking those data, right? We are not taking those data. We are having a car which has probably 10 to 12 sensors. These sensors can send data and can be received, but we are not storing that data. So what data we are storing is limited, but that limited data itself is 2.3 trillion gigabytes in a day. So that is the volume of data that's been generated in this electronic world. And we are in the middle of data, right? So that is the volume of data that's been generated. And velocity, as I said, like it's in US, so do not consider that. There are 100 sensors in a car, that's what they're saying. But I don't think that's there in any cars, but yeah. So they say there are 100 sensors in the car, and those details can come in flow, or like whenever you visit Facebook or any other website, the logs that has been generated will be stored in some database or any other files, even files. It's a data, right? So all these data that's coming in is huge, and it's coming fast every single day. Consider the 2.1 trillion gigabytes of data. It's not just video, photos, or text. It's mostly text. So hope you all have text files. You might be writing some essay for about 500 letters or 700 letters, and it will come only to 40 KB if you do it in Notepad, right? So consider the trillion gigabytes of data you have. And what all are they? Like everything, anything and everything around you is data. Future is data, if you ask me. So whatever is happening around you is data, and that is flowing fast. And variety of data. As I said, you post videos, you post photos, you post likes, even clicking like has been stored, text, all these data. So there are a variety of data that's been coming. And what is veracity? Before explaining veracity, I'd like to ask a question. Like, why did they bring something called veracity? Any ideas about veracity? No? Okay. So what is veracity? It's like, consider an organization that is trying to implement big data in their let's take someone. Let's take Google or Microsoft. I prefer Microsoft. So yeah. So Microsoft. So let's take Microsoft. So every time they take some data, the organization takes data from users. And for example, like how you use your desktop, what are purposes you use your desktop. So they analyze it, they get some data. So whatever data they get, not all will be true for sure, right? Whenever you collect data, it will not be true for sure. It might be random sometimes, it might not fit there, or it might be different, which you cannot group as like other people, like someone like me who clicks randomly in some links. Doesn't make sense, right? So those kind of data should be ignored, and it's been proven that around 20% of the data that 27% of data that's been collected in an organization is proved to be correct. I'm talking about correctness. 27% of data that they have is correct, and remaining is junk maybe, but you cannot come up with a conclusion with it. So that is why they brought in a picture of veracity in it. But to explain clearly, this is an example of Amazon site where an interesting person is ordering a baseball bat, and there is some analytics happening, and in the back, the Amazon gives like this customer also bought other stuff, baseball, glove, baseball, and a mask, right? So a customer who bought baseball bat might have bought a mask for Halloween. It doesn't matter, right? Might be random, happens once in 100, right? Those data cannot be correct. You have to ignore those data. That's why they brought in the picture of veracity in it. Whenever the data is not correct, ignore that. Consider the data that you have most, and use that and process it. Right now, if you go to Amazon, this is an old picture. They've improved a lot. So where big data is currently used, I think this is the right time to tell. So big data. How many of you have a desktop or a laptop and you use internet every day? How many of you search for a product online? So consider that you searched for a product, you bought it. In my case, I bought a Nikon before some 7 or 8 months. So I have 2 different distributions in my machine, Linux distributions. One is Fedora, and another one is Ubuntu. And by the way, I'm an Ubuntu member. I think I didn't tell that before. Yeah. So I have 2 operating systems, and what I did is like when I went home, I tried to order a Nikon 5200 from my Ubuntu operating system, and I didn't. But when I came back here, in my Fedora machine, I tried to order it. And I have it now. But whenever I visit any other sites now, I'll get an advertisement about Nikon 5200 or Nikon 5300 or Canon 600D, 60D. I'll be getting that advertisement, right? How do they do it? Why do they do it? Right? Predictions, advertisements. There are a lot of companies running in US using big data, create advertisements which motivate people to click it. The advertisers will get paid only if they click the links, right? So if they post in some links which you will be interested in, it benefits them, right? So they use your browser cache and then make you click there. So they thought that I will be buying another Nikon, but they didn't know that I already bought it. So they are posting that Nikon every single day, and I'm lazy to clean my cache. That's a different case. But still, I'm seeing those Nikon. So that is where one of big data application is there. I mean, it's it's applied over there. That's what is correct. So big data is applied in one range. That is just one. There are a lot of areas where it's applied, but that is just one. Make sense? Advertisements, that's targeting people. That's another way. It targets people and then gets you right. Google advertisement. Most of them are Google advertisements, and it's all Google, right? So that's what's happening. And let's move forward. I might forget something. I'll just put it in later. So analytics. So we are getting trillion terabytes or gigabytes of data, and we might be having petabytes, zettabytes, and more in our system. So what can we do with that? Let's take Amazon. They have a lot of customers, they have a lot of items, and they sell a lot, right, every year. For example, no, not an example. Let's consider that Amazon sold 2 billion products a year, and they have all these details stored in their machine, right? So to improve their their performance and profit, and to give better customer satisfaction, they can come up with offers, right? Coupons, offers, or like trendy deals. They can come up with that. So how can they use the data that they have and come up with that? Like, they have all the products that's been sold in their database, and they can use this big data to process it and come up with a prediction that this particular product will sell in this range at this particular month, right? How many of you are sleeping? One, okay. Thanks for being loyal. So yeah, so they can use the Amazon's logs or the database that they have about the products being sold, and they can predict how much item is gonna get sold by that particular time. For example, like the major issues that corporates face in this time is space, right? If they are buying an item, they have to store it in a warehouse, bring it back to the store, and then sell it. I'm talking about retailers now, not based sellers. So everywhere space costs a lot, right? So also about the products, perishables or non-perishables. If it's perishables, it's worse. If it's non-perishables, if that particular product's new version is released, old product is not going to sell, right? It's going to be put in the dump. Or people like us who want to save money will buy that. So what can happen is, like, if it's perishable goods, like if company, maybe Walmart, if Walmart is thinking that they'll be selling 60 tons of tomatoes in that particular month, or probably a week, that will be better. So they think that they are going to sell 60 tons of tomatoes in that particular month, and they order it. But when the sales is happening, it's not selling that much. So all remaining are perishable. It's a waste, right? It's going to be a waste, right? It cannot be used anywhere. So yes, what if Walmart applies a logic by identifying, or like they have data about last 10 years in their machines, like how much sales happen at what month and what season, like if there are any celebration that's happening like Halloween or something, or Black Friday, how many items is being sold on that particular time period, and order accordingly. They can save space plus money, right? Right? So that is one other thing. And if they believe that this particular is not going to move faster at that particular time, they can give coupons, right? So these are two things. Remember, one is about saving space and money. One about giving items, or in the short period, identify that this item is not going to move and give coupons. These two are the two major things. Remember it, I'll explain later. So these are the applications where big data can be used to solve, to predict that this is going to happen. Only this much is going to sell, order limited, or maybe order a ton more, not more than that, right? Predictions helping the corporations save money, earn money, give better user satisfaction. So that is the main aim, or that is what big data is going to give to people. Is it clear to now? Any questions?
Even the standard database systems or RDBMS, whatever you use, that can also provide this kind of analytics very faster than the big data, right?
Okay.
I mean to say, right, like if you maintaining everything in a relation, so analysis will come very faster than the big data, because again on the big data you have to post another mechanism to analyze all the data.
Correct.
You don't know in the big data, you don't know where is the start and where is the end.
Right. And what size of data are we talking about?
That's what.
RDBMS cannot hold huge data. Petabytes of data cannot be stored in RDBMS. Right. So we are talking about petabytes of data that is being stored. RDBMS can process things. That's where we are here. Sorry. That's my machine, sorry. I'm a security freak. I just lock it every 5 minutes if I'm not using it. Yes, you can find. So let me give you an example which might clarify you. If not, let me know again. Okay. So there was a research that happened before 5 or 6 years, where they collected details about people and their day-to-day activities. From the time that they wake up, the time they take bath, obviously brush too, right? Brush, eat, what time they go to office, what is the mode of transportation they use. All these details for 20 years has been collected, and researchers identified that people who brush twice a day lives 4 years longer than people who do not brush twice a day. Maybe once or maybe not, that's not considered, but if you brush twice a day, you live 4 years longer. That is one research that proved that people can live 4 year longer if you brush twice a day, right? So identifying hidden pattern where you have an unstructured data which cannot be any meaning to you when you look normally. When you look at it first, it might not make sense to you, but when you try to imply, that's why in big data we have two group of people we call analysts and scientists, right? Scientists are the people who try to find something which is not clearly visible to users. You have data, how can you process it? How can you make the best or take the best out of it? That's why we have scientists. Yeah. So check. So that is why we have check. Technical difficulty. Please enjoy your.
So just for an example, so you are using a relational database for long period. Which database you use? Okay. So you just consider Facebook. Let's leave all the analytics part. Just think about the data being stored in a database. So you are the developer who is developing Facebook. Check. You just consider. You know how much users are there in Facebook. When you log into Facebook, what do you see? There's a dashboard which need to be shown, which has to show all the posts from all your. So how will you handle that? Normally, you just do some relational tables and things like that. So considering the amount, just also consider the amount of data that is there. Thousands of friends, posts, photos, and things like that. How much time will it take? You know that it will be really quick, right? How much time will it take for you to load that screen, home screen?
Here is the topic is to analyze the data, right? It's not about loading the data back.
No.
See, analysis is different from loading a data.
Yes.
Let's not deviate from the topic because it's been deviated a lot from the topic. That's what I thought.
Yes. Okay. So
here actually the analysis part. So in order to load Facebook page instantly, what they do is they don't have a relational database. So they have a regular database. This is actually all the data for a particular profile will be stored in a single location, and that actually brings the complication analysis because there, like if we want all the data of a particular person together, it is pretty fine. It can be put together, but when we have to collaborate or mix data from different users, then actually it is very difficult. There actually this big data come into play.
Yeah,
check. So one other way of approaching that, when you are having your Facebook or Twitter, you're not just seeing your posts, right? You're seeing your friends' posts, and it loads dynamically, right? It's not just loading in your page, but if you are having a friend, like you have 100 mutual friends, and you have another friend who has the same number of mutual friends. If everyone is online, if someone posts in that particular group, if I'm posting, then if you all are my friends, it will come to all your systems, right? It will come immediately. And whenever you like, you click share. If you are using a relational database, you cannot do a parallel processing. If I'm putting a comment, I cannot put it parallelly, right? Either database will get locked. You cannot do a parallel processing. But if it's a node or if it's they call it MongoDB and other text-based database systems. So if you are using that, you can just put it in, right? Anybody can put a command. Or you will not be locking the database. That is one other thing about big data. So yeah, that is one more. And again, let's get back to Facebook and Twitter. Now let's get back to another one. So how many of you are interested in net neutrality, or how many of you are talking about net neutrality these days? How many of you know about net neutrality? Okay. How many of you do not know about net neutrality? Okay, it's a few words about net neutrality. There are a few corporations who are trying to control internet and limit websites to users. If I have to put it in simple words. Mainly Apple has come up with Apple Zero, and Facebook has come up with internet.org. So these two groups are trying to control, and we are fighting against it. India, we are fighting against it. So that's what's happening about net neutrality. So how many of you hashtag in your Facebook and in your Twitter? People who use frequently do it. So if someone wants to analyze how many of them supports net neutrality and how many of them is against net neutrality, right? How can they find it in relational database? I'm not asking you, I'm asking others. How many of you think that, do you think that in relational database you can do something in finding out whether someone posted in supporting net neutrality or against net neutrality? No. So hope everyone knows about database. You have something called archive where you store strings in it. And if you want, sorry? Yeah. So if you take about big data, scientists and analysts, what they do is they know what keywords they have to search for. It's all string-based processing, right? They can process, and to be frank, we're going to see that later. But right now, I'm just giving an intro. Like most of the data scientists these days use a MapReduce program which is written in Java. So programming is done to identify that. It's not just done by querying data. Just it's processing after that. That is what matters. That is why we have scientists. That's what's happening. So again, no, lucky. So yes. Mainly we have big data. We have all these trillions and trillions of data available. So what are we going to do with it? Consider Walmart, as I said, or Amazon. They have all these data in their machine. How can they effectively use it, save money, give better service to their customers, and grow? That will be their aim, right? Whomever it is, they try to earn more, provide better customer service, and save money, right? Save money and earn more, they are different. Hope you already know about it. So, and yes, that course is here. And yeah, for example, if Facebook wants to identify who was supporting net neutrality and how many of us are against net neutrality, they can just use big data to get that detail and can make predictions out of it, like what's going to happen for net neutrality, how are people going to approach it, how many of them are against it, is it huge market that's against us, right? They can do that analysis, market analysis, that's what they call. You can do that, and then they can make next move accordingly, right? And to target people in a particular group, right? So, there are a lot of people who buy gadgets whenever it gets released, right? For example, if someone finds a gadget interesting, or if someone watches a particular product series, if something new releases, they'll go immediately and buy it. Yeah, I'm one of them. So people do that. So what they can do is, like, some people will be reading about some product regularly. So all these will be there in server logs, right? And these server logs can be grouped for a particular country. Whatever data you store based on your IP address, your location, and the country will be there, obviously. So they can group a country's data together, a state's data together, and they can take whatever analysis they want to do in that particular data. They can do it. Can take the response that they want. Like, will the product be successful in the market with that particular price? You might be seeing a lot of rumors about products with price tag in it. So based on these price tags, sometimes Motorola charges their mobile price. I mean, fixes their mobile price. Rumors comes in, people reads about it, puts comment about it that this is too much, this is too less. So they make predictions out of it, they fix a price based on that. That's also happening. So that in that place also we have big data implemented, and where big data fits in enterprise systems. So save money, grow revenue, achieve many other business objectives in any vertical. So yeah, so if you remember, before 10 minutes I told you something about Walmart, one about perishable and another about non-perishable. So you are just seeing about it. So there are two types of applications that we can do with big data. One is operational, the other one is analytical. So operational meaning you have some data, right? You just want to process it and get faster response. Probably a trend in financial sector, maybe like where you get the charts about the price of a particular stock. When it goes up, when it goes down, there will be a chart, right? That particular chart or an interactive chart if you want to search for some details. Trust me, corporate CEOs will not like to work in black box to get some details out of it, right? There will be people giving them some interactive screens where they can fetch data. We can click and sort data based on their requirements. For example, sales on last quarter, sales on this particular week, this particular day. All these data will be there in the particular backend, right? All these data, if they want to take it up and show it to the users, that's operational. Where n number of users can request for data and get it faster. Less activities involved in analyzing the data. Just fetching raw data and then showing it up. For example, in relational database, you can do a count star if you have less limit. But I'm talking about petabytes and terabytes. So all these data can be counted soon, faster, probably. We are talking about milliseconds and seconds here. We are not in processing petabytes and terabytes of data. So, sorry. So we are talking about seconds here. We are not even going for a minute, right? Sometimes people talk in milliseconds. So that's about big data. We didn't start big data yet. So that is about operational, where multiple users query some data, picturize some data, some information. But there are some other activities where, like coming up with promotions, giving up coupons, giving coupons for the users and other services that they provide to the customers. They need more analysis to do on that particular product. For example, if they believe that one particular product's next version is going to get released, they have to close all these products, right? I mean, sell all these products. So they put a discount on it, or they give coupons outside, right? So these coupons will be taken in and then processed. Make sense? Yes.
Just thinking of a hypothetical situation. For example, suppose I'm working with a Flipkart.
Okay.
I have a lot of products are there. It's a relation database, so I can be used there. As you said, we can based on the person. I might have a login. The user might have a login based on which he selects amount. He segregates. He buys, for example, person he goes for different types of cycles.
Okay.
And accessories for that. So next time when he logs in, he can see, okay, new gear system is there, 21 gears. You can upgrade to 18, 19, 20, 21, maybe like that. So so that is an Oracle relation database.
Right.
Assuming Flipkart is using Oracle database. So here, big data to enterprise system. I'm just thinking about suppose this data I need to feed into a big data system, where I need to analyze and understand the person's requirement and give recommendations, saying that a new cycle is coming up, which he was using 18. He recently bought 18 gears. Now a new cycle is coming with a lot of new functionalities with 21 gears. So I need to feed the data, take the data from the relational database, need to feed it to the big data system.
Right.
So how it will be?
So
this is the copy data. This is the dump of relational database which I need to apply on the big data platform, or is it something CSV files we need to import, and how the big data will take the values?
Okay. Relational databases can be used for querying. HDFS handles it. We'll be seeing about it.
Okay.
Where whatever data you give, how many of you use ETL tools, extract, transform, load tools, right? So what you do is that you store it in the master database and process it. So the master database can be a big data system. And processing on that will be handled accordingly. We'll see that.
What specifically I'm asking, how to transform the relational database to a big data that.
Okay, I understood the question. So it's like you have a relationship or already system in your network. Yeah. So how can you transform it, or how can you use it in Hadoop?
I want to transform the data which is there in my big Oracle relation database system.
Right.
I want to export it and import it in my big data platform so that I can do some analysis.
You can put it in normal text files, you can put it in CSVs, you can put it in any format, and DAB is going to get supported these days. There are other databases, NoSQL databases like MongoDB and other databases available. Hive, Pig and other are there, which is going to support fetch-based database systems.
What you mean to say, I need to write some extraction mechanisms. I cannot directly load the data to the big data platform.
You can load it directly just by doing a plugin available. We'll take you through that later. We'll show you. It will be easy. You just have to do that. Like how you copy it to your master database, you just have to copy it there, and you can process it.
To answer your question, that each and every database system follows their encoding mechanism. For example, Oracle follows an encoding mechanism which is not supported by the HDFS. So obviously you have to follow a tool to decode that into the normal text file, to take all the data into normal text file and put it back to the normal file. You say that a text file, so that can be directly pasted into the HDFS. Like it's simple, right? Like unencoded data stored in a large text files. So here, when you discuss about the big data database, right? Yeah, so we should not discuss about 1 GB or 10 GB or 1 TB databases. For example, I have 1 TB database, I want to use HBase. Or else, what do you say that I have to? So it's not supported to use. It's not recommended to use that kind of databases. So big data is only meant for the huge data. So which is not, it's a simply junk actually. So where you don't maintain any relations between relation to load the data back.
Thank you. Yeah. So I was about to show the picture. Actually, this was the next slide. So yes, this is where Hadoop and the big data enterprise system is. You have your DB systems over there. Okay, you have your DB systems Oracle. There can be drivers written. People are working on it in writing drivers for linking it with big data system and processing it. That is also happening in parallel. If you do not want to do that and you want to shift it to big data, as you said, you have to convert it to text. There are tools to do that. You can just load it after that. And to explain about how Hadoop system works, I didn't want to explain at that particular point because we'll be seeing it later. So, where big data fits, or where is big data when you want to process them? So this is big data Hadoop I'm talking about. Big data concept, let's put it aside. Let's think about Hadoop. Hadoop is a system which can process all these data. Okay, I'll explain it later, but better we'll go later. So this is where the data comes from. Your relational database, your OLTP or OLAP database system mechanisms, and your web logs, your emails, your sensors, and your social media. All these data can be stored in any of these database systems, including Hadoop. And we'll see what enterprise Hadoop platform is. I'll explain it later. Like database, you can process it using Informatica or Teradata SQL Server. You get these details using these tools, right? Using Informatica or SQL Server, you can query a data and then get those data. right? From your relational database, you just have to configure it and then get that data. Normally, you do a select star from in a particular connection you do. That's what I was talking about. So that you can do it using these tools, and you can do the same in Enterprise Hadoop also. You can do that, but you need specific drivers for that. And there is something about, and also like since I was telling about the graphs and others, where these DB systems can supply to rich user interface or probably an Excel sheet. There are other big data tools like Tableau and others which will give you better viewpoint to that particular data that you have. You can use those tools to view the data and identify or drill down to what you want. You can sort it based on column, you can sort it based on some filter, you can do that. So that there are user interfaces which do not require a scientist or an analyst to work on data. Simply the backend link will be done and you can simply do it by yourself. That is one side. And the operating systems platforms are Red Hat and other Linux and Windows servers. They are available. That's what the picture is saying. And where did it all start? So big data, it's been a long time that people are talking about big data where they wanted some mechanism to store huge volume of data. I'm talking about 2006, 2005, 2004, those periods, where they wanted to identify a solution to handle all the data that comes in, store that and process it. So where it started is from IBM and Google. IBM has released a paper, I don't remember the paper, didn't grow, but. So Google released two papers, one is GFS, which they call as Google File System, and the other one is the MapReduce. So Google File System is like, let me ask you a question. How many of you have old PCs in your machine, in your home which you do not use? Old PC with probably 128 MB RAM or 256 MB RAM with 10 GB storage and P1 or P2 processor. You can find it in a lot of old institutions. They'll be having all those machines, right? When new machine comes or new generation computers comes, people will not be using the old machines, right? So all old machines will be put aside. So consider Google. Google having that huge set of employees will be having a lot of systems. And when generation shifts, they have to shift accordingly. While doing it, all other old machines, what do you do with that machine? You just dispose it, right? Make it an e-waste. But what Google did is they connected all these systems with less memory, less RAM and less processor, made a cluster, network kind of cluster. And what they did is like they created a file system above it. They combined all processors, all RAMs, I'm talking about virtuality, and all storages and made it work parallelly. For example, if you're having 100 10 GB storage devices, or 100 machines with 10 GB storage, you can combine and make 1,000 or plus database. Whatever, I'm bad in math, so you can count it, and that kind of size database you can make it out of it. That's what they call as Hadoop file system. So how many of you know about Linux and file systems? So your D drive and others, we call in Linux, but we call it as file system. Normally we call it file system. Yeah, so what Hadoop Google file system does is like whatever machine you have internally, it will be connected to each other and will be made as a cloud or a cluster. That's what they call. And you can store data in any, when you push data into Hadoop, it will be distributed in that machine and will be stored. So you will need a pen. So yes, so consider that I don't want to draw 100, so I'm just going to draw 4. So let's consider that we have 4 machines, okay? And we have a Hadoop master system here. Let's keep it aside. I just needed 4 machines there. So this has a 10 gig storage. This also has a 10 GB, and all has a 10 GB storage. And what I'm having is like I'm having around 30 GB data in me, and I'm trying to push it into Hadoop. So what will happen is this data file that you put in will be split into multiple files. A file with size of 128 MB. They call it chunks. Check. Yep. So they call it chunks, where they split the file into size, like 64 MB or 128 MB. Standard is that those two values, either 64 MB sized or 128 MB sized files. The whole file that you're going to put in will be split into these chunks and will be stored in multiple machines. Let's make it 20 GB because we have 4 systems, right? So let's consider old machines. Like, how many of you feel that your old machine will break soon? Most of you, right? So if you are using old machine, it will break soon, obviously. So if I'm storing some data in that particular system, so I'm calling it as a cluster because this whole system will be together, and totally Hadoop file system will be having a 40 GB storage, right? So if I'm pushing in a data, consider this 128 MB chunk of a particular file, that flat file that I put in, right? So a normal text file that I put in. So what happens is, like, if I miss this 128 MB data, I might lose some details, right? Right? And if I'm using an old machine, there is a high possibility that it might fail. And what they do is, like, they follow a mechanism where one file will be available in 3 different machines. And trust me, this is being used by India, Reliance, to save. They have a data center where they store or replicate data in 3 different machines to make sure that the data is available all the time. They call it data availability. So this makes sure that the data is available all the time. But if you look at US, they don't do it. Only India is worried about data that they store, and they store it in 3 different machines. But US systems mostly won't do it. They just do it in 2 machines. So what happens is, like, this particular 128 MB will be here, A. I'm assigning it as A. And it will be there in any other machine here also, A and probably A. We're talking about network where there are 4,000 plus machines connected, right? So this particular data will be split into 128 MB sized files and will be stored in multiple machines. And all these data will be stored in the master system. There are 2 different versions of Hadoop, 1.0 and 2.0. We'll see later, but I'm just explaining in base manner so that you will easily understand. So this particular detail about where this particular chunk of file is stored will be saved in this particular master system. So the master node manager knows where this particular chunk is. So if you are having a 10 GB file that has been split into multiple machines and put, so what this, and if you are querying it, if you are running a MapReduce algorithm, if you are running an algorithm on it, trying to get a result out of it, this master node or this node will take care of identifying which machine is having that data and will send the process to run there. Makes sense? I'm not explaining it big because we are going to see MapReduce later. So I'm just giving you a little intro about what Hadoop file system is. It's just a clustered network where all your hardwares are connected and your hard disks are equally shared. And the information about where data is being maintained separately. Is it clear? Am I speaking in Greek and Latin? No? English? Yeah. So, sorry? Yeah, okay. So that is about GFS, Google File System. So this is one of the papers that's released on 2006. And the other one paper is MapReduce. So yeah, the other one is MapReduce. These 2 are the papers that's been released by Google on 2006. And Apache got interested in big data and they adapted these papers. I mean, started working on these papers and came up with 2 systems. One is again MapReduce. MapReduce is an algorithm or a mechanism which processes that particular data, and it's Java programming. MapReduce is written in Java, okay, to be clear. And we'll see what it is. And Google File System has been adapted as HDFS, which is Hadoop file system, right? So HDFS is the adaptation of that. So this is what they say. This is the master, this is the client, and this particular data has been, so these are the chunks, different chunks stored in this particular client. That's what this picture says. So it's either 64 or 128 MB sized files. So this is about GFS. Now let's look at MapReduce. Picture looks neat, right? Clean and easily understandable. Yep. So we have a 10 GB sized file, which is split into multiple databases. So these are the different database systems. So you have that particular file in all these systems. So when you are running a MapReduce algorithm, instead of running it in the cluster, instead of running it here, instead of running all the process in this system, what MapReduce does is when you push that particular code in it, it will go to the target machine, will save that particular, okay, whenever you write a MapReduce algorithm, you write it and then you save it in jar file, right? You convert it into a jar, executable jar file. So that particular jar, whenever you're trying to execute that particular jar from your master node, when you try to execute, what happens is, if it already knows where this particular chunk of file that you're looking for, right? So it identifies that particular machine. Like if it wants to query about the files which has this particular A chunk, what it does is this particular MapReduce program will go to that particular machine and map process will run there. Map meaning it tries to fetch all those and then store. I will show that later. I'll show an example later. Right now my machine is not functioning properly. So let me just finish this first. So it will go there and then it will do the operation in that particular machine. So operation goes to the target machine instead of running on a server. If you look at ETL tool like Informatica or Data Stage, what happens is all the processes runs in the data stage servers. So this server should be huge enough to handle all the processes. If not, you might kill the process itself or kill the server itself. So that might happen. But in this case, this particular process goes to that particular machine and it works on that particular machine. Okay. So what if this machine is not working after sending this particular file? Do I lose data or do I lose time, or will it not give me a result? Sorry? Right. So this master system monitors all other systems. So if it is not getting a response within a particular time, it knows where the other chunk of A is, right? So it just redirects this process to that particular machine, right? So that is how it processes. And in how replication is happening, like if this machine fails, okay, this was the algorithm written for Reliance. That's what I remember. So if this machine, not for Reliance, first they raised it and then it was written commonly. So what happens, like we have different replication machines, right? Consider a worst case scenario where all three machines fails. Not together, but one by one. What will happen at that particular point? You might lose again, right? So when the system finds that other two machines are non-recoverably out, okay, it cannot be recovered anytime soon. If two machines goes down, the third machine will automatically replicate the same data to other two machines in the same system, in the same cluster, making sure that data is available all the time. Okay. Hadoop handles. So that is how it's happening. So it goes there and processes it. So there are two types of processes. One is map, the other one is reduce. For example, if you are having Shakespeare's poems, that's what we learned when we are starting Hadoop. So when you are using, or when you are trying to find how many times the word "the" is being used, or whenever, how many times that the word is used, the word count in that particular story. If you want to find that, what you do is like you write a separate program called map and another program called reduce. And how many of you know about key and value? key value pairs? Everyone knows, right? So how MapReduce handles is it understands in map and reduce, it understands in keys and values. So if it's finding a character, like this is all been coded in the particular code, Java code, you write, like if it finds a word, it takes that word as a key and assigns a number 1. We assign it, and similarly if you want to do any other process, you can do it. So what we do is, like if it finds a word, we do the word comma 1, making the word as the key and the number 1 as the value. To find word count I'm talking. Again, it's blue. Okay. So so this is how it tries to map. Like this is what map does. It identifies all the, we call it mapper class and reducer class. So I'm talking about mapper class, where we identify the key and then add 1 to it. I'm talking about word count specifically. So I count this word as 1, right? This word occurred 1 times. So this is a key value pair. And similarly, whatever text is there in that particular chunk, it will be processed and will be stored in a set of key value pairs, right? So this is what happens in map. And I should have reset it. So that's what happens in map, and there is something called shuffle. So what happens is, whenever you have these key and value pairs identified, right? So you have the key, right? If you are looking at the word "the," which will be obviously used more times, so that particular word "the" will be taken in the shuffle part, and how many number of times the 1 came, there will be a list of values here. This particular value will be added as a list, key with list of values as the value. So this is already a key value pair list where the key will be identified first. And I mean, I'm talking about all other mappers, like this will be running in other B chunk, C chunk, everywhere it runs. And this particular key value list, we already got this key value list for all the chunks we had, right? The whole 10 GB data. So this particular value key is being fetched, and wherever it's been seen, that particular value that you have, either it can be 1. In this case, it's 1. We have it counted as 1, right? So that particular 1 will be having will be made as a list there. Key with a list of values will happen during the shuffle phase. So it shuffles all the outputs of map class. So whatever output we got from the map is a process, reduce is a process. So map gives these values, and this particular key with list of values will be passed to the reducer. Reducer is where you write algorithm to process this list of values and show the result. So what reducer will give is, it will give D equal to, I mean D has occurred this much time. You can just print it there. Whatever operation you want to show, whatever data you want to fetch, you can process it. You have to write it there in the Java class, and then you have to do it. So how many of you are good at Java? I'm so sorry, big data is not for you. People who do not raise the hand, big data is not for you. Sorry. Not like that. So how many of you are good in querying? Database querying, right? How many of you are used to interactive analysis, where you click columns and others? We have some JSF tools in Java, which helps us in giving better users, enabling, and you can just sort it and all. So those things are there. So people who know about Java can work on MapReduce, right? And people who are good with querying, DB querying, there are companies interested who wanted to use this big data, Hadoop systems. So Hadoop is mainly about HDFS and MapReduce. So there are companies who came in later. I'm not going to explain this, I'm just going to shift. So there are companies who came later and wanted to adapt this. So what they did is, like, they wrote their own algorithm called Pig, Hive, Scoop, and other stuff. So any idea about who wrote Pig? Pig Latin is the name. Yahoo came up with Pig Latin. Okay, so it's a SQL-like system where you can query, you can write your queries and you can query the database. So what happens is whenever you are writing any SQL-like statements in Big or Hive, what happens is this particular code or query that you write will be automatically converted into a MapReduce algorithm. It will be converted into MapReduce algorithm and will be executed in the file system. Right? You understand? So you write a simple query, the user will be seeing only the query, but in the backend, Pig-Latin automatically converts it into a MapReduce algorithm and then runs it on HDFS systems. Sleeping? Is it two? I mean, are you able to follow me? Yes. Okay. So so that is about Pig or Hive. Whatever SQL you write, it will be converted into MapReduce and then will be run on the HDFS systems. So this is how it runs. It goes to a map and then, okay, I didn't explain about reducer, right? So similarly, whatever data we get, it will go to another machine. It can be any one of these machines or can be another machine. Reducer will go there and then will run parallelly. There are a lot of concepts called partitioning. Hope I'm not going to explain it later. Now people will get confused. So there are parallel processing mechanisms and partitioning that can do. When you are reading about Hadoop, please go through that. I'm not explaining it and making it complex now. So so what happens here is, like, see, I just know about querying, or I'm going to use an ETL tool or BI reporting tool or RDBMS, and I can link it with Pig or Hive and run it. So what happens here is, like, there is an overhead here. What's happening here? Any idea? There is an overhead which can be reduced, which is reduced now, but yeah. Now, right, true. So I'm writing a Pig Latin code, and trust me, even if you lose a second, it's a loss. In big data, even if you lose a second, it's a loss. So if you're writing a massive query, like you are trying to join 30 tables or 30 different files, trying to get a result out of it, you are using a SQL to do it. You're writing that big query, and if it has to get converted into MapReduce algorithm, it takes time, right? It takes time to convert and then run. So it is waste. I mean, it is a delay. I do not call it a waste because this was the mechanism that was found. So there is a delay, right? So this delay can be fixed, or this delay is right now getting fixed. I do not say it's fixed, but it's getting fixed. So what's new? We know where the delay is. So what's new? How many of you heard about the word BigQuery? Google's BigQuery. Okay, so so again, everything starts from Google. So Google again released a paper in 2010 saying that if MapReduce is I'm not explaining about column-based or row-based processing. I'm just going to explain in simple. So Google in 2010 released a paper saying that if MapReduce algorithm is going to take hundreds of seconds, probably 500 plus seconds, there is something called Google Dremel, which can do it in 10 seconds. We are talking about petabytes and zettabytes of data processing in 10 seconds. So big data processing and others in cloud, Google uses that Dremel and BigQuery concepts to process. That's what's happening in cloud. So that is Dremel. So this is record based and column based. For example, if you're having a table, you can go record based or record wise, or you can identify a column and process accordingly. Both can be done. So if you're doing the same in SQL using BigQuery, what they say is, oh, where is the picture? Sorry, that is removed. So it's just a picture saying that the row based and the column based orientation takes around 1000 seconds and 500 seconds, where big data Dremel takes only 10 plus seconds. So that is a picture that says, so that is what is happening. Like Dremel has been released. So in 2006, Google released 2 papers, GFS and MapReduce, and Apache adapted it, and they came up with HDFS and MapReduce. So they came up with HDFS and MapReduce. Now in 2010, Google again released something called Dremel. They released this paper in 2010-11. So this particular paper is released. So again, Apache adapted it, and they call it Apache Drill. That's why I said drill into Apache Hadoop. That's big data Hadoop. That's why we had that subject. So Apache Drill, this is still in progress. Development is still in progress. Work is going on, and this is released. The version 0.9 is released 2 days back, which is May 4th. We got the previous release 0.8 on March 31, and the previous release was on November 7, 0.7 version. So this is the latest version of Apache Drill, where they fixed most of the issues, came up with unions and other codes. Like it's again a BigQuery, and it's a BigQuery-like, which is a SQL-like program, where you can write your own SQL and run the queries on the system, and it will be faster, right? And how many of you are techies so that you can set up Hadoop in your machine? Okay, so whatever we talked here, whatever processing happened, the users, whomever is a data scientist or a data analyst, they'll be working on only on this machine, where they'll get a Unix shell and then they'll just work on it. But there is a lot of things happening on the back where big data administrator or Hadoop administrator will be handling. I'm not explaining that. That's a different process. So administration happens on the back, and installation, yeah, I have tried. I have about 20 tries when Hadoop started from 0 point, and then now it's in 2 series. Yes, you have to note, and there are a lot of changes where the resource manager and other stuff comes. Like, yeah, traditionally what happens is this particular, the server that we talk is the owner of whatever process happening inside. So this will have another replica here, meaning another machine which acts as the standby administration server, right? So if this goes down, this will take care of all other processes. But what happened in 2.0 series is, like, they came up with something called resource manager and yarn tool, which maintains all those. So what happens is, whenever the user fires a query, this particular query and processing itself goes to a particular machine. It will not happen here anymore. All these things will be happening here. The resource manager will supply where all these chunks are there, and this particular machine will take care of processing in all other machines. So the load in the particular server is reduced, and this will go to the internal systems. So these all complexities comes in the back, but we don't have to look at it. We just have, being a data scientist or being a data analyst, we just have to worry about how MapReduce or Drill or Pig or Hive runs, right? So let's not go into administration. If you are interested in administration, please let me know. I'll give you the links to whom you can talk. So that is how it's happening. It's advancing. I mean, it's improving itself. That's what's happening. Since it's a community project, people contribute to it, and it's improving. And yeah, that's about Dremel and Drill. So massively parallel processing is included, which is like, if you have any database like NoSQL database, if you want to do a massive parallel processing, it supports that, because it's all chunks, right? It's all processed in a chunk-based one. And parallel processing is much more easier. And I'm not explaining other stuff. It's all like metadata. If we'll be sharing you the presentation, so you can just go through it, and if you have any doubts, you can reach us. We'll explain you. So yeah. So what Drill can do is, like, it's not visible, but let me say, this is a Drill shell where you can just run a command like select star from logs, where directory 0 is equal to 2013, which is the base directory. Okay, so this is an example where you can query directories and subdirectories using where condition. This is a new feature that they included. where like if you are in need of any data in that particular logs folder, and if you have subdirectories, you want to navigate inside and get the data only within that, what you can do is like you can just mention like where directory 0, the next immediate directory is, and here it is mentioned as 2013, and the directory 1 is 6, which is here. So this particular folder, if we want to get details in that particular folder, what is there in that particular folder, you can just run this command, select star from logs where dir 0 is equal to 2013 and dir 1 is equal to 6. So that is the enhancement. Like these kind of enhancements are coming up. There are still work going on. It's not 1.0 yet. It's still 0.9. There are a lot of bugs in Jira. They are still fixing it. People involving in it lot. Like the March 31st release had 246 bug fixes, and the May 4th release had 200 bug fixes. Bug fixes are happening. In parallel, we also have enhancements happening. So it's still upcoming. If you really want to contribute, you can contribute just by going into the site, download. If you see any issues, just report it. You just have to report it. People will work on fixing it if you are not having any idea about coding. So this is a community-based project, so it's happening. But one good thing about Drill is, so if you look at these systems, if you want to install Pig in your machine or Hive or Scoop or anything, you will need HDFS and MapReduce installed in your machine, right? Hadoop should be installed in your machine. But in Drill's case, it can be run independently in your machine. If you are learning it, you just have to download Drill from this site, drill.apache.org, that is the site. You just have to download Drill from it. And once you download that particular file, extract it and store it, you can simply run that particular Drill. You don't really need a HDFS system and a MapReduce algorithm or any other algorithm. It can run independently. And it can be run on a Hadoop cluster also. For learning purposes, for me, I just have to download, extract it, and then run it. It will work. So that is one advantage about Drill. These are some recent enhancements. And before going, I'll just show you a simple example. Not an example, I'll just show how I usually run. So what I'll do is like, yeah, so this is the recent Drill version that got released before 2 days. I'm not finding the archive. Yeah, this is the recent version 0.9.0. I just downloaded it. I extracted it in my folder somewhere. People put it in op, but I just put it in my desktop because I have other versions running on the back. So you have binaries which will help you to start. There are just few commands. You just have to go and visit the URL. I'll just take you there. So this is the site. They say about release notes, and you just have to go about getting started. You will just get all details. There is something called Drill in 10 minutes. I'm not seeing it. You can get the source code if you want. That's one other thing. Just install Drill. Yeah, so you just go to embedded mode where you can just install it in your machine. How many of you use Linux? Wow, that's news. So I'll just click Windows first. You just see, they explain the process here to how to start Drill and all. And similarly, for Linux, you just have few commands. You just have to extract it and then run it. So what I did is like I just ran an instance in my machine. And I didn't type quit. Okay. So this is a shell where I can run my query. So what I'm going to do is like I'm just going to query the sample data. And Parquet is a database system which Apache is maintaining.
So I'm just going to query this particular file, nation.parquet. We'll just see the output. And yeah, I'll explain what that is. But I'm just simply querying it, and this is the result of that particular file. So I'm not doing a Hadoop, I'm not doing a map reduce, I'm just running a query in my local file system. So to explain about the command, is it visible? No, I'll just. I usually do not use gedit, sorry. No, leave it. Okay, so okay, I'll do another one. That might be interesting to you people. There is an option to run it in web, which is still in progress. Sorry, not this. Whoa. So they are working on bringing up a web interface where you can simply see what you have. So I'm just opening the storage devices that we have mapped. So there are drivers written for HBase and MongoDB systems. You can simply enable it and you can run any MongoDB. You can map any MongoDB in your machine and just run it. So and the DFS is your local file system, directory file system. So I'm just, what I did is like I just queried it. I don't think I can, this is still in development mode, so I cannot run query from it. There are a lot of issues, we are working on it. So you can run the same query from your command prompt or your terminal. And interestingly, there is a company called MapR, which is using big data products, and they have come up with a tool, a drill explorer, where you can it looks like a squirrel or SQL developer. You can just open the databases in it and then you can view them. That is all. Yep, it's a Parquet file, it's not a flat file. Parquet is the database. You cannot view it from here. Sorry, you want me to create a flat file? I can create it if needed. Sorry? It's a KB plus. A KB plus. 1.2 KB. It's in my machine. When you are putting it in a cluster where 4,000 machines are going to share it and use it, performance is different. Do not look at, yep. Right. It will not be broken up. It will be a single file stored together. Yes. It's in my machine. I believe it throws that. It took 1.985 seconds in my machine, and it's poor, to be frank. I have loaded it with lot. So we are not talking about KBs. We are talking about petabytes and zettabytes. So when the content is huge, when RDBMS cannot handle those data, you are going for big data. There are a lot of NoSQL databases which you will be interested when you are looking at these kind of concepts. So MongoDB, HBase and other stuff are coming up. Take a look. It will give you more ideas. And why big data is like, it might look slower in my machine, but when you put it in the cluster and when you handle petabytes of data, it will be faster than you think. Right. I was not having time to prepare. I just formatted my machine. So okay, so in the previous example that I showed about logs folder, like if you want to search in a log where there is a line saying null pointer exception, or if the user clicked this particular link, if you want to find that particular string, you can do a like, and that will give that particular content you want. An unstructured data where you just query like where this particular line contains this particular line, word in it. Make sense? Okay. Mainly, like for example, to identify how many users visit that particular page every day, and improve the response time of it. If they want to analyze it, they just have to get the logs and then process it and identify like how many hits happened in that particular URL that they mentioned. It's all unstructured. I didn't have.
So when we talk about unstructured data, that is most of the people that come here, they are only used with this RDBMS or database structure, column, row stuff. So that is, how could we help them to relate it to a NoSQL log?
Like how you can query?
No, not querying. That is relate their mind. That is, they are always thinking in a database RDBMS point of view, because that is what they had seen and they are used to.
Right.
Okay. So this is something completely different. So how could we relate them towards this?
Okay. So probably
just to start with, because just to start with, there is something very basic, very simple,
right,
which could help them to relate to a NoSQL database.
Okay, so consider the product review. You have a product that you sell in Amazon, and you have a lot of comments or review comments about that particular seller. And if Amazon wants to identify those kind of sellers and block them, they have the customer review comments in a particular database. Probably either it will be there in their site or probably in some other websites. They post as a mail to them, like send a mail to those customer support group in Amazon saying that this particular seller is not a good seller. He is giving me a bad product. If they are sending them a mail or if they are putting a comment, how to check all these, and manually they cannot go and find all single sellers, right? And they have n number of mails every single day. They'll have n number of customer comments. They have to consider all the comments plus all the mails that's been received and the response that the particular seller gives, right? All these data will be stored in a MongoDB or any other database, right? In a text format or maybe in a mail. And okay, I missed one point. Like if you, like how I'm saying, if you want to check mail, database plus a flat file parallelly, you can do it in Drill. You have a database like, yeah, probably consider Amazon itself. The customer, who is the customer, who put that request in, and that particular customer's detail will be stored in a DB, obviously, right? So the customer details will be stored in a DB. The customer comments will be stored in a MongoDB, right? Whatever comments he put, the products he bought will also be maybe in a DB, or maybe in a RDBMS database or in a NoSQL database, can be stored there. And he might be sending a mail about the seller. So all these three details can be pulled together and processed together. Make sense?
It makes sense related to Drill, but I'm just thinking about
Okay, so yeah, so you have all these web logs, the number of times that the user purchased.
Just let's think in another angle. Okay, it is just let us think in an angle of I'm a developer.
Okay.
I just know PHP, MySQL, and things like that. And there is a situation where I'm not talking about the big data and things or Drill or anything like that. So most people came for the session. That is where whatever in their mind is like, there is Cassandra, or there can be MongoDB or something like that. If we have to use, that is when should we make that choice, and how does it differ? That is what extra skill should I have to start using it?
Okay. Okay, so relational database. So you know what data you are going to store, right? You know what data is coming in, you know what data you're going to store. A table, you will be defining the table, you will be giving the column names, right? A database, normal database, you give a name, a class, or whatever, country, and you know all the parameters that you want to store. Consider that you don't know anything about what data is going to come in, or it's going to be a text-based system where it might be a customer comment satisfaction. He might fill something, he might not fill something. If you want to catch all those details, and if you think that this data can vary in future, can come in a different format. So if there is a bottom posting and top posting if you're sending a mail. So either I can post my response on top of the previous mail, or can be on the bottom of the previous mail, right? There are people who does that. They'll be either top posting or bottom posting. Meaning when you are replying to a mail, you normally type it, right? Either you can type it in the top, or if you are responding to a particular text, you can type it in the middle. So all these data, it will be unstructured, right? You have to identify that data, like this is a response, this is a previous mail. So those kind of data which can be unstructured. You don't know in what format it's going to come. Customer feedback, those kind of details.
So whether we go to this NoSQL databases, for example, for MongoDB, only if we have that unstructured data?
No, you can.
That is not the case,
Right.
So there is a person who has to architect a system.
Okay.
So how do we have to think about it?
Approach of choosing between the databases.
Yes.
So okay. So how do you choose between databases like known factors and unknown factors? Whatever you know about systems. So to put it in a web perspective, if I am creating a site, or if my customer is wanting a site from me, he tells me like the user will be having this many parameters. You need users with these many parameters. You go with a structured database, or RDBMS, where yeah, Facebook. So what happens is like there are millions and millions of users. So those users, you are not going to parallelly process. I mean, you're not going to access from multiple machines. Even if you are, you just have to select and then leave it as is. It's not going to be updated regularly. So those kind of things, if it's one-time fetch or two-time fetch, you can go with RDBMS. Or if it's going to be a series of data where it's going to come in and you don't have to lock the systems. If you take RDBMS, if you are updating a data, it will get locked, right? But if you take NoSQL systems or any MongoDB or any other systems, it will not get locked. Like whomever is reading or writing from it, it will not get locked. It will be written over and over. So those kind of things. If Facebook is bringing a concept of like and others and compare it with posting, they can just give a number to the post that the user posts and see who all likes. They can put it in a database, RDBMS if needed, to process it. So these can be done, and all these customer, the size of that cannot be defined, right? If you are using an RDBMS, you have to mention what character size you have to put, right? There is a limitation in it. But if you write a long paragraph, you can put it in Facebook, right? All these decision making, it comes on what data is going to be filled, who is going to fill. If it's customer, we have to give an open choice to him, do not restrict him, right? So you choose based on customer view plus what is going to come in. Facebook, if I'm writing a post, it can be a picture. I can upload a picture. I can map it. I can put a text above it. I can add a caption to it. And I can say I'm feeling excited, those kind of stuff which people do regularly. So those kind of details are not structured, right? Those kind of things you go for a MongoDB or a other NoSQL database. Still no?
those type of things are not structured means that can also be structured.
Not always, right? Fine. I think only Deepu is asking questions. Right. Commonly there. Right. Why? Yeah.
Like at the beginning of a project, your customer tells you that I have a list of my customers always comment.
Right.
Can I create a RDBMS with user ID and comments table?
Okay.
Right. That's very much possible, right? So that is still unstructured data, right?
Right.
But you are using RDBMS to account that.
Right.
Correct? We can still do that. However, if somebody says how many times your customer has said hello in the comments, then yes, you will have to do an RDBMS select, which is actually going to cost you time if it exceeds, as you said, terabytes or petabytes of data.
Right.
However, if you are using unstructured data like what you have educated us now, you can do a parallel processing, and that is much more faster than using the RDBMS type.
Right.
Am I correct?
Yes.
So, any other questions?
You are saying it is a file system, right?
Yes, it's a file system. You are querying a file system. You are saving it as a file. Yes.
So at one point of time, we have to lock that file, right?
Okay. One other thing that you want to remember is like you are processing a master data and you are reading it. When you are updating it parallelly, like in MongoDB, it is based on requirements. MongoDB allows you to read and write parallelly, and flat files, if you are processing it in analytics view, if it's in analytics point of view, you will be only reading it. You will not update it. Makes sense?
Yeah. Okay.
Any other questions? See, don't be so cruel, or
So
don't
ask question.
Yeah, don't favor me, and Deepu and me are just opposite.
So the thing is, like, you came here to know about big data. So whatever you didn't get, you should ask.
Right.
Yeah. What about the accuracy of the data? Because it's all the text and it's unstructured.
Right.
So we are getting that from that data. We are getting the results.
Right.
So what's the accuracy?
Accuracy in the sense, if you are querying for a particular data, you will get what you queried for. But accuracy in the sense, there is another view where scientists look at.
Yeah.
Am I getting the right data? For example, when we saw Amazon's ad, the person, Amazon's example, the person bought a baseball plus a cap, 3-hole headwear, which can be used for Halloween or anything. So those kind of details you can ignore. If you see, if it's not fitting a pattern, you can do a pattern matching. There is a lot called machine learning and pattern matching. So I didn't touch that itself. It's a huge topic. So you can do a machine learning or a pattern matching where if it's not coming to a certain pattern, if it behaves odd, you can ignore that. Ignore one particular result and then you can work on other. That's depending on scientists' code. You have to educate drill to do that, or any other Hadoop systems.
What would be the normal hardware requirement, like CPUs, RAM?
As I said, the normal systems will be low ends. That's what Google is using. You can connect any number of processors with high speed or low speed, or with less number of RAM or high number of RAM. It doesn't matter. Even you can run Hadoop in a basic system which can run an operating system.
Hi. As you said, it's dealing with thousands of terabytes of data.
Right.
And you also said like it is taking some duplicates or replicates of data. So obviously it will increase the space, right? Space usage.
Right.
So how we are going to deal with it?
Replication, it's a user's choice. If you feel that your machine might break or you need replication to be done, you can do it.
Actually, as per your statement, HDFS by default it will take replications, and it will. I mean, when one node fails, and it will go to the next node.
Right.
With the node hits, process that one.
Right.
And it will take that chunks result, and it will get back to the user with that result. Right.
Right.
And the processing will go to all the nodes simultaneously, and that HDFS will choose only the first result, whether it is correct or
it will
incorrect,
not
right?
go to the. It will not. If that is what you understood, that is not the case. If that particular chunk is there in 4 machines or 3 machines you configure, it will go to only one machine first.
Okay.
If that machine is not responding for a particular millisecond, or if it's not acknowledging that it received that particular one, or it's not processing, or even if it acknowledged that that particular file is there and it's not responding for some time, only after that this map will go to the next machine and will process it there.
So we don't care about the accuracy of the result, right?
There will be accuracy if you ask me.
So it's a hope, right?
Not a hope. What I can say is, like, if particular chunk is not, you mean that the chunk is not there, but it might or might not respond. Is that the point?
No, it's not about the response, but the accuracy of the result. I mean, if we are asking about, I mean, let's take from your example, Amazon. So it's checking for the quality of its product.
Right.
And let's take a user comments, it's damn good. So we are considering damn as a, I mean, some abusing word. So
okay,
it can be considered as good comment as well as the bad comment.
Right.
So when we are searching for bad comment, and it will come, I mean, damn will come in bad comment result.
You have something called stars there. Yeah, go ahead.
So it will be counted as a bad comment, and the result will not be accurate as we think.
Yeah.
So there is a question about the accuracy, right?
Yeah, that's where data scientists play, and you have something called stars, and the pattern that the scientists look in the particular comment is based on star. Previously, if you look before 4 or 5 years, you might not have seen something like star, right? Recently, they included like 3-star or 4-star or 5-star that you can put and you can give a comment. So why they brought in that particular feature is, like, there is a place where people use 2 negative words, no good, those kind of things. If they come together, which one to take? That is your question, right? You might get a data inaccuracy. That's where scientists identify data and then process it. They know which word makes meaning, and whether also they look whether the customer who is putting the comment is a positive, I mean, it's a verified customer, or whether he buys product regularly, or it's for a namesake. He might be creating one account, buy only one product, and then put a comment saying he is good. Probably I might, if I'm a seller, if to improve my positiveness, I might put one, right? I might put for my name, I might buy to my friend's locality, and then I will do it with my account. I won't buy anything else, right? So it identifies how much. I'm telling about typical Amazon. This is what they do. They identify whether the user is a valid user. So it removes half of the redundancy, half of the false data, and remaining, it looks at like how the customer is rating them, whether it's 3-star or 4-star. That is also there, and it search for words. Damn, usually people will not look at it, to be frank. They look at good, or how the product looks like it's good, shining. I could use it all day long. Those kind of sentence. If it's not having a negative sentence in it, it will be considered as positive. If it is having a negative word in it, it will be analyzed clearly again. It will be taken into another process and will be analyzed. Data analysts are there just for this purpose. You have trillions and trillions of data. Business cannot sit and analyze it. That's why we have scientists who are designed. I won't say educated, I would say designed to do that.
Okay, that star point makes sense. And it's about the updation, data updation. You said there won't be any lock. Data will be updated.
Yes, you push like how you put it into master database.
So it won't delete any data, right?
No.
So it will be keep on updating that.
Right.
So
it's like how you push
if
it in.
4 persons comments, and it will be repeated 4 times. So the amount of the volume of data will be increased day by day.
Right.
So I don't think, I mean, it's look like artificial increase. I mean, user, I don't think it's better than that RDBMS, because in RDBMS, we will be locking one and we will be updating the same data set. But here, observations will be keep on increasing, right? So the processing time will also be increased.
Meaning
for
if,
each and every
if the same user posts multiple comments. So yes, it will be posted as multiple comments. It will be just stored. So as our friend just suggested, it's a chunk of data.
While processing the data, it will be each and every comment will be taken every time, right?
Yes.
So, but obviously the processing time will keep on increasing, right?
Processing time will not. It just takes.
One thing just we discussed about the accuracy, right? Like, no, I say it's not. Why? Because you said that I was searching for the dam. So what is the accuracy that I get the right dam? But here the accuracy doesn't mean that you are searching for the dam and should get the right jams. Here it says that like it will return you, it will return you all the dam words from the table, or else flat files. It doesn't look for that like whether it is a right comment or a bad comment. So you get an accurate dam word rather than receiving a good. You queried for the dam, so it will return all the dams from all the clusters. So you got an accurate result. So you say that it is not accurate when you receive other word than what you queried.
No, actually, from technical point of view, you will search for that particular word or something. That is fine. But in a hierarchy level, managerial level, you will look for positive comment or negative comment. You won't look for the word.
That is a developers or analysis level design. So that they have to do. That is a personal. What do you say that like? It's a organizational thing. It's not do with the Hadoop. And other thing we was just discussing about multiple comments and all, right? Like we discussed that like it will store every word as a indexing. Like the repeats 100 times and all. So unless it missed out the index, the accuracy and time, the processing time will not go up. It will not hit all the time. It will not go and hit the flat file and say that the words is having here 1000 times. It will look at the index and say that it is occurring 1000 times. So it will return you back those 1000. So accuracy will be the same. Sorry, processing.
That makes sense. And what about the security? Data security.
So
sorry.
No props. So as you said, since I was saying it's data scientists who handle it. So it's data scientists who get and analyze. That's why they are designed to get the right words, identify, and then process. That's why writing a MapReduce algorithm or a pig or a hive, you need a data scientist. But when you are just pulling some graphs and all for CEOs, you do not need. When a user or a CEO approaches, they will not be writing anything, but there will be data scientists in the back who will be writing that, or analysts will be doing those jobs for them, right? So security, it will be internal first, #1. So even if you are running in IBM clusters or in Google clusters, you have your specific data store where you store your data, right? Unless and until Google wants to break it, it will not be broken.
I don't think so.
Meaning? If I'm storing it in a cloud, is that what you mean?
See, if we are using the cluster kind of things for banking, see, I was working in IBM and I was in a banking project.
Okay.
And I was in mainframes. So I know, all of us know mostly how secure that mainframe systems are. So customer believe that it's secure and they are going on with that. So we are moving with this one, big data. I didn't hear that it's much secure for banking because it's too much sensitive data. So I think it's useful only for the advertising and
those are operational data. Again, if you go to the previous slides, like there are two kinds of data, right? Like operational and another is analytical data. So if you go for a operational data, so it should be stored in such a structure where a breaking of structure should be a difficult one. So when you go to the analytical data, anybody can break the structure, security structure. That's what they designed about it. So again, we should not relate the operational data with the non-operational data. It's never been good for the banking as till now, right? Like so, because they always store a relational and operational data.
So it's like market conditions. Always conditions apply.
Your social security number will never be saved in Hadoop for sure. to give a small answer for that. As we said, it's junk of data. It's not a normal data that you look. Your question?
How about concurrency or like maintaining all the 3 copies same?
Okay, as he was making a funny comment, it was Reliance who needed 3 copies of a particular file. Normally Hadoop handles it and puts it in 2, but if and only if needed, it will go for 3. Usually, any system, if you're putting a data in a system, the Hadoop file system automatically handles it. If the system is not going to recover, the node managers knows it, and they'll just replicate it again. Only 2 nodes will be there. I mean, 2 copies of the same file will be there. Right? Right. If it is going to come up, if the system knows that it's going to come up, if it knows or identifies, Hadoop knows whether the system is going to come up or not, it will not replicate it. If it is not going to come up within the process is getting over, it will not replicate it. It will wait for it because there are a lot of processes. I just told 10 GB as an example. We'll be having petabytes and zettabytes of data being processed. So it has considerable amount of time. It has at least 10 seconds. If the system is not going to come up for 10 seconds, it will go to the second node and it will use it. If the system is not going to come up for share for most of the time, or if the Hadoop is not aware of what is going to happen in the system, if it needs a DB, the Hadoop administrator to look at it, then it will replicate the file. Make sense?
Sorry to interrupt you. As you just mentioned node, I'm just asking this question. Are we following any near node, far node kind of concept here?
No near node, far node. Everything goes to the particular node and runs.
No, because it depends on the traffic, right? Network traffic. So
okay,
we have to use some near node, far node.
Okay, so what happens is it's not just near node, far node. If I am processing a chunk here, this machine might be holding 6 to 7 of the same file, right? It will not be holding only one part of my file. I'm talking about petabytes of data which is split into 64 MB or 128 MB. So this particular machine will be having more than one file of mine. So what happens is push happens only once from my machine. This resource manager or administrator push the MapReduce algorithm. I'm talking about MapReduce. This pushes only once to the particular target machine and it runs there. So push, it takes time, few seconds, but not more. And processing happens in that machine and transfer happens accordingly. Once all mappers are complete, it'll not all mappers, even when it's going on, reducers will start running on. Yeah.
Hadoop Apache, some version 1.4 or 1.5, I think. That I just read for HDFS file system, it will just send that MapReduce algorithm. It will just send that program to each and every node. Even duplicate nodes, and it will take only the first response as the correct, whether it is correct or not. It will take the first response and it will ignore all the other responses, so that it can just save the time. Because we cannot expect all the nodes to be very near to that computation system. One can be in Italy and one can be in Japan. Well, we are processing from India, so it will send in both ways. One to Italy and one to Japan, and it will take the first result as correct one, and it will just give us the result, and it will ignore the second one. Just like that I just read. I don't know.
That was 1.4. We have 2.x series now, and we have Yarn and Resource Manager which maintains that. So Resource Manager identifies which machine has that and it allocates tasks. So just like how we have Task Manager, they have a Task Manager. The administration stuff that comes in administration, they handle that.
Going deeply inside the technical.
I'd like to, but we don't have time. And why do you think that? Actually, I should have asked this question at the first, because we have technical difficulties, I forgot. What do you think is the motive of Facebook buying WhatsApp? I can install it for free, right? I can install it in my mobile for free. Why Facebook bought it for 19 billion?
Yeah, there are much private concerns, because I may ask a friend that I am going to buy that particular phone. What's your opinion about that? So Facebook can immediately get that and bring me advertisement for that phone. It sounds cool, but that is creepy.
Facebook watches you, not just God. See, I know that all of you stopped using Messenger anymore, right? Facebook Messenger. How many of you use Facebook Messenger these days? One, okay. Do you have WhatsApp? And still you use Messenger, okay, so yeah. So consider like almost everyone. Now, who doesn't have a WhatsApp account here? Okay, I also have. So, yeah. Right. Yeah. So Telegram again, yes, but it's not open source. They say it's open source because your client is open source, but the server and the Telegram server they run, it's not open source. It's again proprietary and they store their data. You don't know what's happening there. They say so. It is, but not sure how people will be using it. We'll see. So yeah, so they just bought it to have all your data, watch you like, what are you going to do, what are you doing, which all groups you're active on. Like it gives your personal information, right? Every single information that you have. I believe the only person who cannot be predicted is Joker. All others can be predicted. That's what I believe. And yeah, it's all prediction and machine learning. There is a lot more that's happening in the world. Predictions and what you are going to do. How many of you watched Captain America, the Winter Soldier? You remember that guy saying like, I forgot that name. Hydra watches you, like we know what you are going to do. We take your previous election votes. You're buying patents. We know what you are going to do. We'll target you. We'll kill you, right? If you are against us, we'll kill you. That's what they say. They get everything and then they can do anything. So how many of you watch Iron Man movie? How many of you know Jarvis? Jarvis. This is just additional info. So did you know that Jarvis is available for download online? Oh, so by the way, what is Jarvis? No chorus song, just a solo song will be better. What is Jarvis? Stand up or get the mic and tell, so that everyone will get knowledge about it. Iron Man's suit, okay.
His artificial intelligence personal assistant.
Jarvis is a system which has artificial intelligence and assists him, right? So that is Jarvis, and it's available for download online. People wrote Jarvis already. You can download it and use it if you want. It's all machine learning, prediction, and others. There are a lot of things that's happening around. Just open your eyes. Anything and everything that's happening around you is big data, and it's data. Every single thing that you do around you has data, and it's been stored now or will be stored in future and can make predictions out of it, and anything can happen in future. If you really want to be safe, stop using electronic devices. Do not create any data. Go to a dark forest, stay there. And thanks all for being a wonderful audience, and thanks all for being active and shooting questions. And yeah, and also thank you for not kicking me more, like one of you doubts, and others are like, so good, you are my friends. Yeah, thank you. Thanks all.
Thank you, Mohan. Okay, so it was an awesome session, and I expected more simple, silly, foolish questions from everyone. Yes, so smaller questions would always help us to understand things from the base. So for example, that is, you should have asked questions like difference between different terminologies. Whatever new term that you heard today, you could have asked the difference from that with the other one. So whether that is Hadoop, then Hadoop, that is, you might have heard about it a lot, but you can ask that whether it is a database or a system, or an environment for this noise, then heard about NoSQL. So all those questions, comparison, all those would be, I expected that those are the basic questions from you. And those type of questions are something that we should in a Coffee DBG that would help everyone to come up to the same level and then discuss about the next level things.
Please remember that Socrates is your guru and please ask questions every single time. Because we try to implement that, because if you're not asking questions, you are not learning. That's what people say.
So anyhow, it's 7:20 already. Okay, and and thanks a lot, Mohan. And there is a small memento for Mohan. Yeah, so Zahir is the organizer for this Coffee DBG, so you can just hand over it to Mohan. So regarding Coffee DBG, those who are new for it, that we started it 2 years before, and there have been a lot of speakers. We discussed about a lot of different topics, and we just started with big data, and we may have more session on that. Previously, we were having a series on front-end JavaScript, JavaScript series, where we talked about almost all the frameworks like AngularJS, Knockout.js, then about Node.js. So we normally start the session with introduction, which is very basic, very low level. So what is it? And then we go to the terminologies one by one. So we just thought this as an introductory session, and you can surely expect more clarify your questions. Okay. And Techno Geeks is a community that we have with a lot of people from our Technopark as well as outside. We have a Facebook group, G+ group. So I request everyone to join that. You will be receiving a feedback email where you could always give us your tips for improvement, and all the slides. All the slides means the slide which you used will also be shared there, and you can start communicating and discussing about the topic there. So keep in touch. And here there will be a barcode, these QR codes for the Facebook pages that we have. So one is the, of course, you should be part of the Techno Geeks one. Thank you for coming. That's all for today. Bye.